In this Onshape tutorial, we'll be creating this XS Filament Chute for the Bamboo Lab X1 Carbon. It's going to be a two-piece design with a collector basket and the main chute that's magnetically going to attach to the back of the 3D printer. So join me as I walk you through how you create a model like this in Onshape. Thank you. Don't forget to like and subscribe. Let's do it. The first thing we're going to do is import the base printer model for the X1 Carbon. To do that, I will click the Insert New tab or the plus button. You then click Import and you navigate to your folder where your downloaded file is, and you just click and you open. For me to actually get to this file, I just did a simple Google search. So you see that now, a simple Google search for X1C card. I typically default to GrabCAD because I found that to be a very good repository for file documents, and then just navigate to the file that I wanted. You're kind of missing the most important part here, and then we'll cover that in just a bit. So what I'm going to do now is just show you, once I've downloaded this model, how this actually works. The most important part here is actually kind of the last string at the end of that file there, which is the file format. A lot of times when you're downloading CAD files from the internet, you're downloading what's a mesh-based file, which is an STL file, and it doesn't really give you a lot of flexibility other than to just send to your slicer and print. You can do some basic things with it with Onshape, I think, other than you can shrink and you can expand, but that's just about it because it has no surfaces or faces for you to click on. For you to have the most flexibility with this, you actually want the top three files I just showed there, what we call in the business neutral formats, so STP, IGs, and Parasolid. You are able to do a lot more editing and a lot more rich CAD with those folders, with those file formats, because they do have actual faces that you can select and you can click on, and I will demonstrate that in a bit. So to actually download the folder, we're going to navigate back into Onshape now. Once that folder is downloaded, what we will then do is click on the plus button, navigate to the folder, the file that we wanted, and then Onshape is going to bring two options here, an options window here. And what you want to select here is combine into a single Path Studio, as that's actually kind of the most simplest things for you to do, just to grab. So what it does, it combines all of the paths into one single Path Studio. Those three tick boxes there, I would say you can probably ignore it. Sometimes I like to click the third one, join adjacent faces, when I'm downloading a PCBA, because those tend to have like a lot of little parts, and they help to kind of shrink it a little bit. Otherwise you might just end up with thousands. But none of these three are important in any weaknesses. You can click the first one if you had like a color that you want to bring in. And what you need to do is you click import, and you can see like the little bell shape there. Onshape is working and is importing that folder. And that folder now has been imported. That file has been imported, and you can see it here. And this is the STP format. To kind of illustrate what I was talking about earlier, I'm going to export this out into Onshape by just right clicking on the tab and click export, and export that as an STL. I'll probably select Corsair for the resolution, export that out, and then import that back into Onshape as an STL file, and just demonstrate the flexibility you get with these two file formats. So I'm going to click the plus sign again and then select the STL file. You can see the difference in the file formats here. The top one is STL, the bottom is STP. You click import. Onshape gives you a more limited options window this time, which is just to pretty much select the units. I've already deleted some of the paths I don't need on my STL file. To do that, all you have to do is just right click on the paths in the paths section, and just right click on the path that you don't want and just click delete, or select and just select delete on your keyboard. So as you can see now, as you saw briefly earlier as you can see now, you can see like this is just a mishmash of triangles. There isn't really much to select here. So I've selected sketches here, and the only thing I can really select there is just the planes. I can't select any of the faces to do any sketch against. If I go back into the STP file, you can see now that all of the faces here are selectable. So I've just created a plane and about to create a sketch on that top face there. I'm going to project a sketch on one of the features there. So creating a circle out of that handle, and actually draw a circle on the top there and extrude it. Just showing you some basic features, some basic demonstration here. And as you can see, I'm able to actually sketch off that surface and make significant edits to that part. And you only get this by using, the neutral formats I talked about earlier, STP, IGs, and Parasolid. If you want a lot of flexibility, I would say avoid STL files. All right, let's get back to the modeling. All right, guys, let's get into this. I will be using an existing model of an X1 carbon here to actually start off my sketch. So I've offset this plane here by about 150 meters, from 50 millimeters from the bottom of the printer up to roughly where the position of the chute is. And I'm going to use the project sketch feature here to actually map out the initial edge radius of the printer. And what you're going to see me do here is offset that by about 1 millimeter, or is it actually 0.5 millimeters, actually looking at this now, to map that so it's actually not on the same plane as it's not on the same position as the actual printer. But I think I will change that later on, but let's continue. Then I'm going to set up the initial chute sketch here for that side. So I'm placing my dimensions, and I'm on this channel, I'm big on constraining your curves, right? We don't want to see no blue lines here or no blue dots. So that's been set up right now. And then I will put in so there's an offset tangent there, isn't it? So now I need one more there to actually map the vertical position of that point. So I've done that to be about 152 mil from the origin. I'm placing both of these dimensions from the origin. And next thing I'm going to do here is just draw that out roughly to the position where I want that to go. So the chute itself is probably going to be about 140 mil away from the printer, right? So, and that distance represents not the final width of the connector basket, but where the connector basket will interface with the chute part. So that's what that means. I just need a bit of space there. So I'm still working on the sketch for the chute, and then I'm going to try and close this off now. I would use a horizontal constraint there to make sure that those 2 points are level. And now I will close that off for a fully constrained sketch. Next thing we're going to do is we're going to extrude this down all the way to the bottom of the printer. So I will extrude, I believe, up to face here. So you can actually see as I rotated back here where I actually placed the plane of the cuff. So of the sketch. So it's just right at the bottom of where the chute ends. So yeah, and then but I actually also want that to go kind of up and down that. So I've added a second direction to the extrude to actually go kind of roughly to the upper third of the chute. So next thing I'm going to do here is I'm going to set up and extrude a sketch that I can extrude cut off, but that kind of gives me the slope that I need. So you can see there's a slope to this line here. So over the next couple of moments, I'm going to be constraining that so that it is fully defined. And then what I will then do is extrude, cut that up to the face of the printer, and that gives me the slope for the chute. So I'm placing my dimensions right now in the right places. I think I need an angular dimension here, which I'm about to do, or which I will do soon after I've placed the height. Actually, okay, I didn't go with an angular dimension. I went with just constraining the heights here, and that again gives me a constraint curve. So I'm now going to do the upper part of that chute, because remember, so what I've done here is I've actually kind of placed a parallel line there. So the two chute lines are parallel to each other, so that kind of initially constrained that lines. But I have two lines because obviously there's an upper part and a bottom part to the chute, isn't it? You don't actually need that whole block that I've currently drawn. You could have achieved this actually thinking about it with like a chamfer on both edges of that block, but I'd like to, as much as possible, work with sketches because I feel like I can control that a little better. And right now, what I'm going to do now is just finishing completing this curve here so that I will have two complete enclosures on the original extruder that I have. So the idea is that what will remain here is just the areas in between the two regions of the area in between the regions of the sketch itself. So so that's kind of the plan here. So I'm just constraining those curves now. I think I might make a modification here on the original one. Actually, I didn't. So now that those is closed, now you see the two areas at the top of the curve. So I can then extrude cut that, right, all the way to that surface, and then that leaves me with just the main body of the chute itself. Okay. Now that I have the kind of the block shape of the chute, I then need to now create the internal channels of the chute itself. To do that, I'm going to use a shell feature. But before I do that, I'm actually going to place a little chamfer. You see where I'm placing it now at that edge there. And that chamfer is the kind of where the collector basket is going to merge. It's going to meet the chute. And I place that because I want to place that before the shelling so that I don't have to do any kind of internal chamfer on there to match the outside chamfer, and that's always important when you shell. I mean, in hindsight, I think I probably made this shell a little bit early. I should have probably radiated all of the outside of this block before actually creating the shell, but I didn't actually meet some of my rules there. But now I've done the shell. Now you can see kind of the internals of the chute itself. I've just dragged that variable up that I created for the wall thickness so I can easily change it on the other part, and I've dragged that to the top so that it can now be used in the shell feature here. So I've just added one last part there as part of the shell feature. So now that that's done, I can actually now start creating the card for the collector basket. So what I'm going to do is I will draw a rough shape of what the collector basket looks like. As I mentioned, the collector basket is going to have like a chamfer that matches that internal chamfer there. But I'll walk you through how to create that. So the first thing I'm doing here is just creating the sketch for that second part. I'm creating the rough shape. I'm going to get that all the way to the end of it. So I've kind of zoomed in here so I can capture that edge of the chute part. So now that that's done, and then once I've done that, I don't actually need to constrain. Actually, I needed an additional constraint, so fine. I suppose I needed to in that scenario. And then what I'm just going to do now is just create the rest of that sketch there. So that's done. I've just completed that all around, and now I'm going to give it a size so that I can constrain this sketch here. I'm not sure how big I want this to be. I think I changed this a couple of times through the design. I can't actually remember the final dimension I settled on, but this is based on your table and the amount of space you have. So by all means, use whatever size is comfortable for you. So what I'm doing now is I'm now just offsetting that initial sketch that I make, and I'm doing that because I want this to actually fit inside of the chute part itself. So where that chamfer is there, I need the collector parts to fit in there. and I've given that like a very good offset there. I think I give it about 1 millimeter so that I don't actually have to ever worry about that not fitting, because these are, big pieces of plastic, right? So you want to actually guarantee that as much as possible. Again, because I created that downstream of the sketch, I have to move it upstream of the sketch so that I can actually call that feature there. I've addressed this topic in previous videos in the past when you're using variables in Onshape. So now that allows me to actually create a block extrude of the collector basket. What I'm doing is just literally just renaming some of my sketches, because again, it's actually one of the things that you should always also do, because it allows you to find your way a little better. So I'm just going to quickly rename all of those 3 sketches there. Up to you. You don't have to do this step. You can just ignore it if you want to. So I've renamed the first one the chute sketch, and now this is the sketch for the slope of the chute, and then I'm going to rename this last one the collector basket, or a basket. I can't remember what exactly. Okay, I did give it collector basket, so that's that there. But yeah, by offsetting that initial sketch that I made, right, I can pretty much guarantee that this is going to fit inside of where I need it to fit, and I don't have to actually ever have to worry about any sort of interfacing that being too big, essentially, because as I mentioned, that's a massive piece of plastic, right? So I want to actually guarantee that that fits. So now I am just extruding the rough shape for the collector basket here. So what I'm going to do next is actually use the boolean feature to actually subtract the collector basket from the chute. But watch a tiny detail here. I'm actually going to keep the tool. So I want to actually retain the collector basket here. So the keep the tool is actually ticked. So what this does is that it removes the collector basket from the chute, leaving the part that's actually not inside of the chute body. So a new partition has been created there, and it's just a case of me just deleting that. Now the chamfers at that edge is matched. What I then need to do is to make sure that that's actually not, size for size. So I need that to also be offset away from that edge there. So I'm going to cheat a little here and just use the move face feature. I don't really like using synchronous feature, but sometimes we're all going to take shortcuts, right? So I'm going to use the move face feature to actually offset that by 1 millimeter, and I'll call the offset feature here. I will call the offset feature here to do that. So now that's spaced away from that feature, or from that part there, and that's actually to guarantee that that part, when it's printed, it stays kind of always below where the kind of the slope ends, right? So that everything kind of falls in, and I don't get any sort of expansion or shrinkage as part of the print. So now I've just kind of removed the old printer now, so because I really don't need that part anymore. And now what I'm going to do is I'm going to shell the collector basket, and before I shell that, I didn't make this mistake this time. I actually kind of I added rads to all of the outer edges of that, so that when I shell it, the shell takes into account those rads, and I don't have to do any internal radiuses around that. It's just a nice little shortcut that saves your life. It might not matter too much here, because this is like it's a fairly simple geometry, but when you're doing complex geometries and you want to actually mirror your outside radiuses on the internal parts, this step is actually quite vital, that you actually create all your radiuses. Put that exit the sketch, exit the radius, and then shell, and now you can see all of the radiuses I created around the outside is now replicated on the inside without me having to do any additional modeling. Now you can kind of see the makeup of the actual design itself. So we've got the chute, and we have the collector basket. What I'm doing here is just adding a wall to the end of the chute, so that I only essentially have one path. When the excess filament is falling, it doesn't actually come across that side and end up on the floor. I think even in this case, the collector basket might catch it, but it's always better to just put a design in, so I don't make a mess, or I don't create a mess when I'm actually printing here. So I'm just going to quickly add that wall there, and I know the wall thickness. Again, I'm just going to call that wall thickness feature there, which is the 2.5 millimeters. and then just add that to that. So now I'm going to exit the extrude here. Now that wall is created, and the last thing I just need to do is just chamfer that edge there, so I have some clearance there on both sides of the collector basket. Actually, I'm going to make that as big as I need to, because again, these are big pieces of plastic, right? You want them to fit, so you want to somewhat guarantee that in the modeling that there's always clearances between these parts here. So that's what I'm doing here. So yeah, I will just increase that rad until I get the amount of clearances that I want. I think now I've got it, so I'm quite happy with that. So now the basic part is actually now formed. So I've got the two parts that I need. I've got the collector basket and I've got the chute. So the next thing I'm going to do here is create this the opening for the actual XS filament. As you can see from the card right now, the upper wall is actually blocking the chute. So I'm just going to do a quick sketch there. I'm going to use that top edge there as the locator for it. So again, it automatically constrains the curve towards that, and I just add a couple of dimensions from the sides. I wanted it to be kind of symmetrical here, to be equal, so I played around a little bit until I got the dimension that I wanted. I think it was probably about 5 mil on each side, and obviously then we need to constrain the height of the opening itself. What number did I end up here? Let's see. Yeah, how about that? 65 mil. I think, yeah, that's red there because I selected the wrong dimension. I wanted to dimension the height. So, okay, it was about 70 mil. It also needed to be short because I actually wanted to kind of kiss kind of the bottom edge of that slope there, right? So that it doesn't become, it doesn't go below that and risk anything getting trapped in there. So that's perfect right there. Yeah, and then I think that edge probably needs a bit of a rad. And actually, did I move that up? Okay, yeah, it looks like I moved that up there. Oh, I moved it down further. So it's, yes, you're right. I moved it down further. So it's actually kind of below the chute side because you don't want that getting stuck internally. I don't think it'll have made that much of a difference, but you know, we're seeking functional design here. So, you know, it's absolutely necessary. And I'm just renaming that sketch there so that I can easily find my way should I ever need to edit this. So I've renamed that chute opening. So the next thing I'm just going to do here is to just extend the left face of where the chute touches the printer at the back, just by a tiny amount, just to give that part a little bit of strength. Because you can imagine that's a weak point there, isn't it? It could just be something that can easily snap off. So I'm just going to extend that just slightly, but not enough to actually block those vents there at the back of the printer. But you know, that's totally optional. It wasn't strictly necessary, but I did it in time. So the next thing I'm going to do here is to now start looking to add the dowel pins that actually connect the collector basket to the chute. This process here, I would say you can skip it. I think for me, sometimes in engineering, you want things to actually go where you want them to go. So, and for that, you need to actually add features that actually enable that. So I'm starting with a sketch on just one of the horizontal faces. You can pick any face here, whether or not it's on the basket or not on the chute. Or I'm just going to dimension that circle and extrude that out. So, but the extruding here will only be on the collector basket. So I would select that when I'm extruding to only actually merge that to the collector basket and not the chute itself. So that's what I'm doing here. So that creates just a shaft or a dowel pin as the kind of the male part of this connection. So right now I'm just going to adjust that just to the right length. Again, you can choose whatever you want here as long as it's actually not touching kind of the base of the rig. And as you can see here, I've adjusted the merge scope here to only actually be just for the basket and not for the chute. After making a tiny adjustment here to the diameter, the next thing I'm going to do is I'm going to look to pattern that horizontally across the face of the basket so that I have two of that feature. So we're going to click into the linear pattern feature in Onshape and then select feature mirror, because this will be a feature mirror, sorry, a feature pattern, not a path pattern. So we select the feature that we want, which is the extrude that we made, and we use that edge as a direction, and then we will set the horizontal distance of that. So one step I'm going to take here is to actually create a variable to actually control the distance between those two dowel pins, and this is quite important, particularly given the fact that I have multiple parts here, right? And I would like to actually replicate that part on the chute. Creating this variable allows me to actually update that feature from the variable on both parts without me having to actually undo features within the sketches. So that's one advantage you get from doing that. And as you know, on this channel, I love creating variables because it just makes your CAD a little bit cleaner. So now that those parts are created, I'm going to replace face it because I actually don't need the top part of it. So I'm going to replace that with just the slope of it. So that kind of goes, that kind of top part of it goes away, and only leaving the bottom pin. And then I'm just going to add, I've just added a chamfer there to make the insertion into the corresponding hole on the chute easier. It just gives it a bit of a lead in while inserting it. So next thing I'm going to do is then I'm going to then create the female part of that on the chute. And like everything we do in Onshape, it starts with a sketch. I could have actually nested a lot of these sketches in one, but I chose to separate the sketches here a little bit. So the first thing I'm going to do here is to just use the offset feature to offset my previous sketch, and I've given it a wall thickness there because the hole that we're going to create itself actually also needs a wall, right? It needs I want a wall around it, right? I just don't want it to be like just like a hole in the middle of the chute. So what I'm doing here is creating the wall for the hole, and as you can see just a few minutes ago there, I actually called the wall thickness variable that I used there because I want even wall thicknesses across it, and it just makes editing a little bit easier. So now that that's done, I'm going to do the same thing that I did before, which is to pattern this bus that I made. And because I already created a variable earlier, I'm just going to call that variable right now in here. So I'm going to call the Dowel H variable that I created earlier, and that just sets the linear spacing between these two holes to match what I created on the basket. So now that the walls for the hole has been created, I'm going to now create the hole that the dowel pins in the connector basket slot into. I'm going to give this hole a very generous dimension. So as you can see, I'm selecting about 12.5 millimeters compared to 10 millimeters for the hole. This is just the fact that because I'm not really looking for precision here, right? I just want that to fit, and I want to guarantee that it fits. So this is a choice that you can make, but I've gone for as practically big of a dimension as I can here. But you know, it really doesn't matter. We're not really creating like, you know, precision machining here with, you know, fine tolerances and, you know, slight fits. So the 12.5 is just fine. Next thing I'm going to do is just select the depth of the hole because I actually don't want that to be a true hole. Again, it's just a personal choice. It really doesn't matter in the long run. I'm just going to fiddle around with the depth here until I get to the depth that I wanted. So I'm going to bring back the basket now and do a section view so that I can get a clearer view of how deep that this hole is to be, because again, I don't really want to, you know, risk anything not sitting the way I want it to sit here. So I'm going to do a quick replace face and then section view so I can get a clearer view. And as you see, Onshape did something very subtle here, as I was actually messing about trying to get the correct depth. As I increased the depth here, Onshape brought in the collector basket in scope. I've just circled that part there in red. You can see part 17 pop into scope there as the depth actually overlapped with the depth of the collector basket, and it was something I didn't actually spot when it happened at the time. So now the pinhole has actually completely disappeared because I've actually now just somewhat extruded through it because I created that hole. So that's something you have to watch out for, that when you have features interfering or in the path of other features, Onshape can sometimes bring it in scope. And again, I didn't spot it. So now the hole is created. I can now have noticed that, oh my God, my hole is missing. And in real time, I didn't actually have an idea as to what had happened. So you're going to watch me fish around a little bit trying to figure out what happened. I'm going to try and drag that feature up and around, that wasn't the issue. So I kind of was wandering around there trying to figure out what was going on. So I then went back into that feature, the old feature here, and just removed part 17 out of the scope of that, and that fixed it. Now that my hole is back, I'm just going to do like a quick I'm going to drag the feature bar down now to actually allow that replace face to come back in scope. And then I'm going to do a quick check with the section view, and then you notice now that my the hole on the dowel pin is now back on the collector basket. So now I've just done a quick replace face, and I'm going to chamfer the entrance of the hole just to give this a bit of a lead in, and then we're just about done with this feature. As I mentioned, this feature here was it wasn't strictly necessary, but I just wanted this to sit, where it needs to sit without you kind of sliding about, because you can imagine you can get like a situation then your table is not level. What will happen is that if that's not properly constrained there, you can get your conduct or your basket kind of sliding down and away from where it is. So this just kind of helps it stay in place. And as you can see now, I've got the right holes and the right sort of clearances between the dowel pin and the hole on the chute. So now that feature is added, the last feature we're going to add to this is just some holes on the side of the chute so that the chute can magnetically attach to the back of the printer. I've just hidden away all of the other parts of the printer here because it was kind of getting in the way and I needed a clearer view of that back panel. So as everything, it starts with a sketch, and I'm just going to use the project to sketch feature here to actually get the bottom line of that chute there. And then I'm going to offset that. I think I offset here in total by about, again, this is up to you, right? You can choose any number that you want. So I think I set it on 10 mil there. And then what I'm going to do is just create a bunch of circular bosses for a magnet, right? I think I had some line around there was about 10 mil in diameter. So I set it for those. I mean, in hindsight, you can watch as I do this, but I think looking back at this and looking at the way this actually kind of prints, sometimes when you do print this with in a 3D printer, you kind of get like a bit of a seam around that hole, and it makes it difficult to actually insert the magnet, no matter how much. I mean, to get around that, you can give it a lot of clearance, but then again, you want your magnet to sit in, isn't it? You don't want it kind of falling out, so you can actually also make that hole too big. But I noticed this while I was printing it, but I wasn't going to, redo this. I just had to kind of work with what I got because, we're engineers. It's what we do. So in hindsight, maybe that internal circle there, you actually want that to be like an hexagon so that you have 4 sharp corners there, and then you should have no issues getting your magnet in. Or you could have something like a circle with a lot of clearance and have some sort of crushed ribs inside of it that actually gives the magnet some retention. So just keep an eye out for that here. So what I've just done is I've just created the external diameter of that hole there, and I'm going where the magnet sits, and I'm going to use the hole feature here to create the internal diameter of that hole there. So I'm just going to select the center there, use the mate connector because I didn't spot it in time, and then change that to the diameter of the magnet with some clearances. I'll mess with the depth here to make sure that the magnet is actually sitting in, but for a 10 mil magnet, I think I settled for like a 0.3 mil diameter here, just to, after some experimentation and some test prints. But just keep it in mind that you're probably likely going to get a seam around that, so you probably want to make that internal diameter like an hexagon, or use cross strips as I mentioned. So now that the first hole is done, what I'm going to do is I'm just going to pattern that. So because I want 3 of them, so I'm going to do one pattern across that line there, using my sketch line as a path, and this will be a feature pattern again. So the direction will be the line there. I will offset that so it goes back the other way. So again, size this as you want, as you feel. I think I sized this because I still want both holes to be on the back panel. So I played around with that a little bit just to make sure that they were both on the back panel, and it's actually, because the back panel is the only panel that's magnetic on the X1 carbon. The side panels are kind of plastic, so if that spacing there was too much, then you're getting onto the plastic part or onto the curved radius, and you're not going to be attaching to anything. So now I'm just going to I settled for like a triangular pattern here for the magnet. So I'm creating the path for the second magnet. So I'm just going to dimension that over there. Again, we should always dimension our sketches and keep it constrained. So I'm going to dimension the edge of that line there, and I've given it an angle, and then I'm going to use the linear pattern again to do another feature mirror, but this time I'm going to use that line there as the path, and I'm going to mess with that. I think I give it about 30 mil just to actually space that about right onto the edge of the line. So now I've got my 3 holes for my magnet, and I will add a quick chamfer here to give it a bit of a lead in. And then at this point, I thought I was done, and practically and functionally, the part is complete, other than just adding a few rads. Yeah, the model is complete and where we need to be, and I thought I was done at this point. I closed things up, I sent it to my X1 carbon, and then I realized the bed was too small. And in a way, it's kind of one of my criticism of this of the X1C here, that is actually, compared to like the other more recent offerings from Bamboo Labs, right? They tend to have bigger beds. This one here, it was too big, so I had to jump back into the CAD to actually split that into 2. So congratulations, you get to watch me do more CAD. But this was a fun learning experience overall, and I hope you guys are also learning from it. So to do that, as I mentioned, I need to split this into 2, particularly the chute part, so that I can print it in 2 pieces. And for me to be able to do that, I need to add some joining features at the split point. So that's what we're going to do. So the first thing I'm going to do here is just put a plane where that line is, because I kind of had a natural line where that curve was formed, so I use that as a splitting point. And then I'm going to use the split face feature with that plane that I created there as the split point. So that's what I'm doing now here. Now we split that into 2 parts. We have the top part of the chute and the bottom part of the chute, and it's actually good because now that we created a plane there, right, we can actually use it to make the same sketch that will actually form the joining feature for both the top part of the plane, for both the top part of the chute and the bottom part of the chute. And we just really have to use one plane to do that, because it's kind of the same plane on both sides, right? So what I'm doing now is I settled for like a Dowel pane type joining feature. So So I'm starting with a sketch here of the feature. So I'm just going to use the Dowel feature in the sketch feature here to create that. Sorry, it's called a slot. To create that, I'm going to dimension that. I only need about 1 mil here, so that it sits within the wall thickness of the chute. So I'm going to add that midline, and the top part I believe is going to be the male part, and the bottom chute is going to be the female. So I'm just moving it around there to check that I've got enough, and then once I was happy with it, what I would do is, with the length of it, is I would add a chamfer just to give it a lead in at the very tip of it. Once that's done, I need to then mirror that to the other side of the chute. So I'm going to create a center plane here by selecting the 2 sides I want the plane to be around, and just select a plane, and Onshape automatically figures out that I want the mid plane. And then now that the plane is created, I will mirror that feature that I just created across to the other side. Easy peasy. But remember to select both the extrude and the chamfer here so that both of them are mirrored. The next thing is I'm going to add that top part and use that plane and the sketch onto the bottom sketch, because remember that plane is actually kind of on both sides of the chute, so you don't actually have to recreate it or even recreate the sketch. If you want to, you can just use the same sketch. So what I'm doing is just creating the female part of that. So this part here is just going to be an extrude subtract, just as like a hole, and I've given that 3 mil so that I have enough depth, because given the previous part was up to 2.5 mil long, and that's just what I've done here. Again, I don't really have to recreate any of the 2 planes. I could just also mirror that across, and that's replicated. So one thing I did realize is that both of these are actually size for size, right? So, and if we go ahead and print it as it is right now, we risk it not fitting together. So I'm going to use the rollback bar and roll it back to the original sketch and offset that outwards by 0.2. So what I'm trying to achieve here is that the male part, the size of the male part stays the same, but the offset out, the 0.2 offset, now becomes the new size for the female part on the lower chute. So I'm just going to go back now and just give that back the chamfer that I already placed in. So I'm going to drag that back down, drag the rollback back down, and then just move that back up again, hide the top chute, and then go to the bottom chute, and then just use the offset that I create to actually make that all bigger in there. And then I need to reapply that chamfer. And now we have the right clearances between both mating parts. So the 0.2 is sufficient here. I tested it out before and I knew that that was going to work based on my current print settings. And with that, this part is complete and ready to be sent off to the printer. So thank you guys for joining me in this video. This was a really fun process. It was actually one of my first earlier prints with this printer, so I had to figure out a couple of things along the way, do like a bunch of test prints, and it was a learning process for me as much as it was for you. So thank you guys for watching. Do me a favor, smash that like button, subscribe to the channel. It really helps us out when you do that. So thank you. As this print finishes, catch you on the next one. And if you like to use this model, the model is available on my Maker World profile. Link in the description for the video. Thank you, and catch you for the next one.